In section 4.3, we want to talk about vectors. Vectors are quantities that involve both magnitude and direction. If we have a quantity that has a magnitude, has a length, and has a direction, it's pointing somewhere, it's called a vector quantity, or vectors in short. But if we have any quantity that has a magnitude but doesn't point any direction, it's called a scalar quantity, or scalars. So as you see in this picture, we have a line segment which has a direction assigned to this line segment. So that's why we call this one a directed line segment. And if the initial point of this line segment is P and the terminal point is Q, we call this one as a directed line segment PQ. And since in geometric, any directed line segment is a vector, we can show this one as a vector PQ. So to show the vector PQ, we just write the initial and the terminal point and then put a vector notation on top of that. And to find the magnitude or the length of this line segment, which I will show you in later how we can find the magnitude, we show this notation for the magnitude. We put the name of the vectors inside these two lines, or you may see in some books that we just have one line around the vectors. If we have a vector PQ, which the initial point is point P with the coordinate of x1 and y1, and the terminal point is Q with the point of x2 and y2, the position vector, or the vector PQ, will be calculated by x2 minus x1 and y2 minus 1. And this is the notation that we use for showing the components of the vectors. And for any vectors has to have an x and a y, and the x will be calculated by subtracting the initial from the terminal. So just remember, we need to use the terminal point first and then minus the initial point for x, and the same for y. The terminal minus initial, y2 minus y1. And this is how we show a vector's component. So every vector has two components, a and b, which a is along the x-axis, b is along the y-axis. And to find the magnitude or the length of this vector, we always use the right triangle property. For example, let's look at this vector v. That's my vector v. So the component of these vectors are a and b, which means along the x-axis, the length is a, along the y-axis, the length is b. And as you see, we can create a right triangle here. And when we talk about the magnitude, we are talking about the length of this vector, which is the hypotenuse. And to find the hypotenuse, we are using the right triangle property, the Pythagorean theorem, and that's why we use this formula, which is the square root of a squared plus b squared. And to find the direction of the vector, we need to find the angle that the vector creates with the x-axis. We need to find this angle because this angle tells me the direction. And to find the angle, we need to find the one trigonometric function of this angle first, like sine or cosine or tangent. But since the component of the vector are a and b, we just have the opposite and adjacent, we can use the tangent for finding the angle. And we know that the tangent of any angle in the right triangle is opposite over adjacent, which is b over a. And to find the exact angle, we need to use the tangent inverse of b over a. So by using the tangent inverse, we can find angle or the direction of the vector. And by using the Pythagorean theorem, we can use the magnitude of the vector. So these are the notation that we usually use when we talk about vectors. So if you look at the books, you may probably see that they show the vectors with a bold letter, like V and W, as you see here. But when we are writing on paper, since we're not able to make that bold part, we just put an arrow on top of the vector's name. And the same for the magnitude. For the magnitude, they just put the name of the vectors inside of the lines, but we put with the vector sign above the vector's name. Okay, let's look at an example. First example, it says find the magnitude and the direction of the vector, which the initial point is -8 and 1, and the terminal point is -2 and -5. So if I want to graph this vector, I actually, this one. The initial is -8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, which is this point. Terminal point is -2 and -5, which is this point. And that is my vector PQ. Okay. But what's the direction and the magnitude of this vector? To find the direction and magnitude, we need to find the component of the whole vector, not the components of the initial and terminal point. So we need to find the vector PQ first, the component of these vectors, which we call them A and B. How we find these components? By subtracting x2 minus x1, y2 minus y1, subtracting the initial from the terminal point. So x2 minus x1, y2 minus y1. And x2 means the terminal point, which is -2 minus -8. And y2 means -5 minus 1. And we know that negative times negative is positive. -2 plus 8 is 6. -5 minus 1 is -6. These are the components of my vector, P and Q. And if I want to graph this vector, the vector always starts from the origin. So the vector 6 and -6 starting from the origin. So 6 is along the x-axis, 1, 2, 3, 4, 5, 6. -6 is along the y-axis, and that's my vector PQ if I want to graph it. Okay, now after finding the component of this vector, now it's time to find the direction and the magnitude. How do we find the magnitude? Just using the right triangle property. So the magnitude of vector PQ, a squared plus b squared. A is 6, b is -6. 6 squared means 36. -6 squared is also 36. And 36 plus 36 is 72. And if I want to simplify this, I know that 72 is 2 times 36 because I already added 2 36 together. And I know the square root of 36, which is 6. So the final answer is 6 root 2. 2 stay under the radical because it doesn't have a root, but 36 is a perfect square. We can just bring it out as a 6. So that's the magnitude. And to find the direction, I need to find the tangent of angle theta. That's the angle, which is b over a. And that's -6 over 6. And that's -1. Now we're asking ourselves, okay, theta is the tangent of the angle is -1, which means the theta of my angle is the tangent inverse of -1. Okay, what is an angle which its tangent is -1? So I know that, as you see in the graph as well, the angle is in the fourth quadrant. And it's also in the negative direction. That's why the answer for the tangent is also negative. If I can just say that if the tangent is -1, means I have an angle, the tangent of an angle, then multiply by negative, because tangent is an odd function. We can bring the negative out. So what is it, an angle that its tangent is +1? It's 45 degree. Now, since we have -1, we say -45 degree. So this direction is -45 degree. And you see that this angle is in a negative direction. That's why we show like that. You may say, okay, my angle PQ was this one because of the initial and the terminal point. Why? Now we have another vector for 6 and -6, because they are equal angles. It doesn't matter, you just look at the first one, number 1, or look at number 2. We call them equal vectors. When do we have equal vectors? When we have two vectors that they have the same magnitude and same direction. As you see in part A, these two vectors are called equal because they are on the same direction and they have the same magnitude, same length. But in part B, the vectors have the same magnitude or the same length, but with the different directions, so they are not equal. In part C, the two vectors again have the same magnitude, but in opposite direction, so they are not equal as well. In part D, the vectors pointing the same direction, but not the same magnitude, because one of the length is just shorter than the other one. So these are not equal as well. So that's why in previous example, we can use this vector number 2 instead of number 1, because they are equal vectors. Okay, so every time we use this formula to find the components of any vector using the initial and terminal, we find a position vector. A position vector means a vector that starts from origin but is still equal to our vector with the same magnitude and the same direction. Next example, we want to show that these two angles are equal to each other. Angles are equal if they have the same magnitude and same direction. If I want to show these two angles are equal, that means I need to show that they have the same length, same magnitude, or the same direction. First, how we can show they have same length, same magnitude? We need to find their length, but we have the initial and terminal point. So it means that we need to find the component of each vector first, and then using the square root of a squared plus b squared. Or we can do both of these steps at the same time by using the distance formula, because the distance formula is subtracting the initial from the terminal and then using the Pythagorean theorem at the same time. So what do? We just replace number that we have for the initial and terminal for each of the vectors. So in vector u, we need to subtract the y values starting from the terminal. So we say 6 minus 2 squared, and subtract the x values, -2 minus -5 squared. 6 minus 2 squared, -2 minus -5 squared. And we know negative times a negative is positive, and -2 plus 5 is 3. So 3 squared plus 4 squared, which is 25. And the length of the vector, or the magnitude of vector u, is 5. We do the same for vector v. This time the terminal is 6, initial is 2, 6 minus 2, and 5 minus 2. 6 minus 2 is 4, 5 minus 2 is 3, 4 squared plus 3 squared, which is 25, and the square root of 25 is 5. And as you see, we showed that these two vectors have the same magnitude. So halfway done. Now we need to show that the two vectors have same direction. To show the direction, we need to find the angle that they create with the x-axis, or this line. You need to find this angle. But finding the angle, it may not be as easy that we think. It's possible, I don't say it's not, but we can, instead of finding the angle, we can also find the slope of the line, because they are lines. They are line segments. If I find the slope of each of these lines, and if I show that the slopes are the same, a slope means the tangent of that specific angle. And that means if they have the same tangent, which means they have the same angles. So to find a slope, so we need to remember the slope formula for a line, which was y2 minus y1 over x2 minus x1. And we need to find the slope for both vectors. So for vector u, we have 6 minus 2, negative 2 minus negative 5, which is 4/3. And for the slope v, we have 6 minus 2 over 5 minus 2, which is 4/3 again. When the two lines have same slope, that means the angles that they create with the x-axis are the same. That means they have the same direction. So now we verified that the two vectors are equal because we showed that they have the same slope and the same magnitude. Same magnitude and same direction. Yeah. Scalar multiplication. Scalar multiplication means multiply a number with a vector. So like number 2, you have vector v, and they ask you to find the vector 2v. It means that's a scalar multiplication. We have a real number. K can be any number, a positive, a negative, a radical, a fraction. When we multiply a real number by a vector, we call this product a scalar multiplication. But something that's important, if that number, it's a number, any number except 1, when you multiply that number by the vector, you are changing the magnitude of the vector. And as you see in this picture, we have a vector v with its magnitude. You see the length of vector v. Now when you multiply by 2, you are multiplying the length by 2 as well. So the magnitude is changed. 1/2 v magnitude is, or the length is in half now. But if the number is positive, like these two 2v and 1/2 v, your vector is still in the same direction, just the magnitude or the length may change. But if the number that you're multiplying is negative, you're changing the magnitude and the direction, because that negative will change the direction. And as you see, the direction of this vector is just pointing down instead of pointing up. Now, how do we do the scalar multiplication? For a scalar multiplication, we need to find the absolute value of that number and then multiply by each component of the vector. If my vector's components are a and b, and if I multiply the vector by k, which is a number, we need to multiply k by both components a and b. So we say k times a and k times b. And as I said, if k or that number is positive number, you will still have the same direction vector. But if k is negative, you will have an opposite direction vector. Let's look at an example. I have vector v with the components as -2 and 5. And I want to find this scalar multiplication, 2v, which means I need to multiply both components by 2. 2 times -2, 2 times 5. And that's my new vector. If you are multiplying by the component, you just multiply the exact k, no matter if it's a positive or negative. But if you're to find the magnitude, you need to have the absolute value of that number multiplied by the magnitude. how we can add or subtract two vectors. If we have two vectors u and we want to find the sum of these two vectors u plus v, the sum of the vectors are called resultant vector. Okay, and how we can find addition of two vectors? If we have the vectors component, for example, I have vector u, which is 2 and 5, and I have vector v, which is 1 and 3. To find the resultant or adding the two vectors, we just add the component, the corresponding component, 2 plus 1, 5 plus 3. But to show it in geometrically, for adding the two vectors, we need to position the two vectors such that the terminal point of vector u, it's the initial point of vector v, as you see in this picture. Then when we position the vectors in this form, any vectors starting from the initial point of u to the terminal point of vector v is called the addition of these two vectors, adding these two vectors, or the resultant vector. We do the same for subtraction, but for subtraction, we need to add the vector v by the negative of the other vector. So for subtraction is still an addition, by addition between one vector with the negative form of the other vector. For example, if I have vector v and vector u like this, and I want to find v minus u means v plus negative u. That means vector u must be multiplied by negative, which means the direction must change. So for vector u, I will keep the same length of the vector, but in the negative direction, which gives me this one. Now this one is negative u. Now you want to find the sum of this vector with this vector, the purple ones. So how do we find the sum of these two vectors? We can position them such that the terminal point of vector v, it's the initial of negative u, as you see here. Now the answer is the vector starting from initial of v to the terminal of negative u, which is this one. So remember, when you have two vectors, make sure for addition, you just need to position in form that, for example, u plus v, you can just have this v over here and then find the resultant. But for subtraction, you need to, if you want to find u minus v, you need to find minus v first, which shows in the opposite direction, and then you need to position vector negative v over here and then find the resultant. That's v u minus. We have a few more steps. But let's see how we can find the sum and difference of these two vectors. We have two vectors u and v. We want to find 3u plus v. Okay, 3u plus v means multiply vector u by 3 and then add it by v. Okay, my vector v is 3 and negative 2. And if I want to multiply by 3, it means I want to do the scalar multiplication here. Scalar multiplication means multiply both components by 3. And 3 times 3 is 9. 3 times negative 2 is negative 6. Now I need to add it by vector v. How do we add? Just corresponding component. The first component, 9 plus negative 1. Second component, negative 6 plus 4. And that is 3u plus v. Now we are done. To find u minus 2v, I need to just copy down the vectors first. Vector u minus 2 vector v. Okay. We can multiply. We need to do the scalar multiplication first. But for the scalar multiplication, remember we have -2 here. So you need to multiply -2 with both components of vector v, which -2 times -1 is +2, -2 times 4 is -8. And I just bring down vector u. And what do we put in between? Now it's addition, because we already multiplied the negative. So now we just need to add these two vectors. So u minus 2v is just 3 plus 2, -2 plus -8, which is -10. And that's the final answer. So what are the unit vectors? The unit vectors, or I and j unit vectors, are the vectors with length of 1 and in a direction along the positive x-axis or y-axis. So I is a unit vector along the x-axis, j is a unit vector along the y-axis. And the length or the magnitude of the unit vectors are always 1. So as you see in this picture, we have I along the positive x-axis or j along the positive y-axis. So what does it mean? It means if I have a vector v, which its component is 2 and 5, it means we have two unit vectors along the positive x-axis and 5 unit vectors along the positive y-axis, which means I will have 2i and 5j, because the lengths of each of these vectors are 1. So I can rewrite the vectors coordinates or components in form of I and j, and this is how we write them. So if you have a vector v, which is from origin to point A and B, you can rewrite that in form of I and j. It's the x component, B is the y component. Or A is called the horizontal component, which is along on the x-axis. B is the vertical component along the y-axis. And this form of AI plus BJ is called a linear combination of the two vector I and j as well. But to find the magnitude, we are still using the same formula, square root of a square plus b square. So next example, we have a vector v, 3i minus 3j, and we want to find its magnitude. So first we need to sketch the vector. To sketch the vector, we need to know its component, a and b. So what is a in this vector is 3, and what is b is -3. Because a is the number in front of the I, b is the number in front of the j. So a is +3, b is -3. Now what do? We need to sketch. We need to find these 2 points. We need to find the point which x is 3, the y is -3. And then sketch the vector starting from the origin. So 3 and -3 is this point. Now we will have this vector from the origin to that point. After graphing the vector, now it's time to find its magnitude. To find the magnitude, we just need to use the same formula, a squared plus b squared. A squared means 3 squared, b squared means -3 squared, 9 plus 9 is 18, and if you want to simplify, you can rewrite 18 as a 2 times 9, and you know that the square root of 9 is 3, so you will have 3 root 2. So that's the magnitude or the length of this vector. Let's look at another example. We want to sketch this vector, 3i plus j, and find its magnitude. So first of all, when we have a vector, we need to know the components of the vector, a and b. So when vector b is 3i plus j, it means the a or is 3 and the b is 1. And there's no number, it means it's 1. But if I give you this vector, just 3i, and it doesn't have any j, you can say a is 3, but the b is 0, because there is no j, means the b is 0. But if there is a j, it means b is 1. Okay. Now, after finding the component of the vector, your vector is a vector 3 and 1. That means you need to find this point as the terminal point. So to sketch the vector, we need to find the point 3 and 1. And starting from origin, you can graph the vector. That's the vector. Now we need to find the magnitude of the vector. To find the magnitude, we are going to use the formula that we always use. So which is a squared plus b squared. A squared means 3 squared, b squared means 1 squared, 3 squared is 9, 1 squared is 1, 9 plus 1 is 10. So the answer is the square root of 10. And I cannot simplify square root of 10 because 10 is 2 times 5, and none of the 2 and 5 are perfect square that I can bring them out. So if you want to write the vectors in form of I and j, when the initial point and the terminal point is given to you, you need to subtract the initial from the terminal and then find the component of the vector and then write it in form of I and j, as we already mentioned. So to find the component, you just need to find x2 minus x1 and y2 minus y1. And if you put them with I and j, you will have the vectors in form of I and j. For example, we says let v be the vector from the initial point of -1 and 3 and the terminal point of 2 and 7. And you can see the vectors in the picture. It says write this vector in terms of I and j. Okay, so if you want to write these vectors in terms of I and j, you just need to find the component of the vector first. Right now, you just have the initial and terminal point. But to find the component of the vector or the component of the position vector, you need to subtract the x and the y values. So x2 minus x1, which is 2 minus -1, y2 minus y1, which is 7 minus 3. And these are the components of the vector. And if you put them with I and j, you will have in form of I and j. And negative times negative is positive. 2 plus 1 is 3. 7 minus 3 is 4. So we have 3i and 4j. Or you can rewrite your vector component in form of 3 and 4 first, and then rewrite it in form of I and j. We want to find the component of this vector with the initial of 3 and 2, terminal 7 and 4. Okay. We need to find the component of the vector first. To find the component of the vector, we need to subtract the x and subtract the y's. So x values are 7 minus 3, y values are 4 minus 2. So the components of the vector are 4 and 2. If you want to rewrite it in terms of I and j, you can say 4i plus 2j. So how we can add or subtract vectors if they are in terms of I and j? Exactly the same as what we did when we had the components of the vector. Just add the components for the I term and the components of the j term. That's it. Just if it's subtraction, we subtract them. If it's addition, we just add them. So We have i's, so the components of I term is a1 minus a2 or a1 plus a2. The components of j, b1 plus b2 or b1 minus b2. Let's look at an example now. We have vector v and vector w. We want to find the v plus w and v minus w. So to find v plus w, we need to add the vectors. Add the I component, which is 7 plus 4, it's 11i. Add j component, which is 3 minus 5, it's negative 2j. So we have 11i minus 2j, because 3 plus negative 5 is negative 2. To subtract them, we need to subtract the components. V minus W means I need to have V first and W after that as a second. So V minus W, 7 minus 4, 3 minus negative 5. 7 minus 4, which is 3i. 3 minus negative 5, which is 3 plus 5, is 8j. And we have set 3i plus 8j as the answer. For a scalar multiplication, when we have a vector in terms of I and j, again, we are going to multiply the number by both components a and b. Multiply any number by the I term and j term. For example, I have vector v, which is 7i plus 10j, and I want to find 8v. 8v means multiply the vector v by 8. So it means I need to multiply both components by 8. And 8 times 7, 8 times 10. 8 times 7 is 56i. 8 times 10 is 80j. We want to find negative 5v. That means we want to multiply the components of vector v by negative 5, which means negative 5 times 7, negative 5 times 10. Negative 5 times 7, which is negative 35i. Negative 5 times 10, which is negative 50j. So what is a zero vector? A zero vector, as its name says, is a vector with magnitude of 0. It's not actually a vector, it's just a point when the magnitude is 0. And the zero vector is assigned no direction because there is actually no vectors, because we just have a point. So we cannot, assign a direction to a point. But if we want to write the zero vectors in terms of I and j, we need to know that the both components of I and j are 0. So zero vector is 0i plus 0j. And you can see some properties of the vectors additions in these slides. So we have a commutative property, which means we're adding two vectors. It doesn't matter which vector comes first. U plus v is always the same as v plus u. If you are adding, we have associated property. If you're adding 3 vectors, you always add 2 vectors and then add it by the third one. And it doesn't matter which 2 you add first. U plus v first, then add by w. That's exactly the same as if you add v plus w first and then add it by u. Additive identity tells me that if I add any vectors by the 0 vectors, I still get the same answer because 0 vectors have a 0i and 0j. And additive inverse means if I add any vectors by its additive inverse, which is negative, if it's vector u, it's negative u. And if I add them together, I always end up to the 0 vector. And you can also see some properties of the scalar multiplication when you are multiplying a number by a vectors. If c and d are just numbers, are scalars. And if you want to multiply them by vectors, these are the properties that we always have. For example, if you multiply number 1 by any vector, nothing changed. You still have your vector. But if you multiply 0 vector, you get a 0 as an answer. If you are sum of two scalars and you want to multiply them by a vector u, It's like that you multiply the same first scalar by vector u and then added by second scalar by multiplying by vector u. That's called the distributive property. Now we can find a unit vector. We said that I and j are unit vectors, are the unit vectors along the x-axis and the y-axis. But now we want to find a unit vector which is still the magnitude is 1 because it's called the unit vector, but it's in the same direction of our vector. Not that is not in direction of x-axis and y-axis. It's in direction with our vector. How we can find that? By just dividing the vector by its magnitude. That's it. That's all we do. We find the magnitude of the vector and then divide each component of the vector by its magnitude. Because you know the magnitude is just a number. Then just divide the components by that number. Let's see an example. For example, I have a unit vector. I want to find a unit vector in the same direction as vector v. My vector v is 4i minus 3j. And I want to find a unit vector in the same direction as this vector. So what do we do first? We need to find a magnitude first. And to find a magnitude, I need to square the component and then add them together and then take the square root. So square root of 4 squared, negative 3 squared, which is 25, and the square root of 25 is 5. After finding the magnitude, you know that you need to divide the vector by its magnitude. The vector is 4i minus 3j. And you need to divide each component by the magnitude, which is 5. So you will have 4 over 5i minus 3 over 5j. This is a unit vector, which means if I find the magnitude of this unit vector, the magnitude should be 1. But that's a unit vector along the direction of vector v, with the same direction of vector v, not in the same direction as the x-axis or the y-axis. After finding the unit vector, if I want to show, if I want to verify that the magnitude of this vector is 1, again, I need to use the formula for the magnitude. This time we s square 4 over 5 and to negative 3 over 5. 4 over 5 squared is 16 over 25. Negative 3 over 5 is 9 over 25. And remember the negative, when you square a negative, negative times negative is always positive. And 16 plus 9 is 25 over 25, which is 1. And the square root of 1 is also 1. So you verify that the length of the magnitude of this vector is 1, which confirms this can be a unit vector with the same direction as the vector v.